Oftentimes when we're working with limits, we may have a question such as when the limit as x tends to c of f of x over g of x, and the limit as x tends to c of f of x equals the limit as x tends to c of g of x equals 0, or the limit as x tends to c of f of x equals the limit as x tends to c of g of x equals plus or minus infinity. When this is the case, that is, while evaluating the limit as x tends to c of f of x over g of x, we arrive to a solution that happens to be 0 over 0 or infinity over infinity plus or minus. When we have such a case, then we'll employ L'Hopital's rule, or LHR for short. So L'Hopital's rule basically tells us that if we take the limit as x tends to c of f of x over g of x, this is the same as taking the limit as x tends to c of f prime of x all over the limit as x tends to c of g prime of x. So basically it's telling us that if we're taking the limit as x tends to c of f of x over g of x and we encounter a 0 over 0 or infinity over infinity, then what we can do is take the limit as x tends to c of f prime of x all over the limit as x tends to c of g prime of x. Let us consider an example. I suppose I had the limit as x tends to 1 of the natural log of x divided by x squared minus 1. And I proceeded to solve the limit as x tends to 1 natural log of x divided by the limit as x tends to 1 of x squared minus 1. And recall that the natural log of x function looks like this, xy. This is x equals 1. So the function will cross 1. And as x tends to 0, y tends to minus infinity. Okay. This is y equals ln of x. And y equals 0 when x equals 1. So going back here and evaluating when the limit as x tends to 1, the natural log of x go to 0, and the bottom limit as x tends to 1, x squared minus 1 will also go to 0. So here we have a case of 0 over 0, which would indicate to us to use L'Hopital's rule. So let's take a look. So L'Hopital's rule tells us that if we take the limit as x tends to 1 natural log of x all over x squared minus 1, we can evaluate this by taking the limit as x tends to 1 and taking the derivative of the top, and the limit as x tends to 1 and taking the derivative of the bottom. So we proceed, we say limit as x tends to 1, the derivative of ln of x is just 1 over x, and the derivative of the bottom, the derivative of x squared minus 1 is just 2x. Now if we evaluate the top, the limit as x tends to 1 of 1 over x, that's just 1. And the bottom, the limit as x tends to 1 of 2 of x, that's 2. So our answer is 1/2. Let us look at another example now. Let us look at a second example. Suppose I had the limit as x tends to 0 of 1 minus e to the x all over x. And I continued in the regular fashion. I said limit as x tends to 0 of 1 minus e to the x all over the limit as x tends to 0 of x. Now the top, as x tends to 0, e to the 0 will be 1, so 1 minus 1 will be 0. So the top will be 0. And the bottom, limit as x tends to 0 of x will just be 0. So again, we have an indeterminate form. So this leads us to use the L'Hopital's rule again. So let us employ L'Hopital's rule. We have limit as x tends to 0 of 1 minus e to the x all over x equals the limit as x tends to 0, the derivative of 1 minus e to the x all over the limit as x tends to 0 of the derivative of x. So the top will be limit as x tends to 0. The derivative of 1 minus e to the x will be, the derivative of 1 is 0, and minus e to the x will be minus e to the x. And the bottom, limit as x tends to 0, the derivative of x is just 1. So we have the limit as x tends to 0 of minus e to the x. E to the 0 is 1, so we'll have minus 1 on top, and the bottom is 1. So our answer is minus 1. Isn't that wonderful? So we reduce the limit that of x tends to 0 from 0 over 0, which is an indeterminate form or meaningless, to resolving it using L'Hopital's rule to an answer of minus 1. Let us consider another example. In the first two examples, we had cases of 0 over 0 and we used L'Hopital's rule. In the following case, we're going to look at a case where we have infinity over infinity. So let us consider the following. If I had the limit as x tends to infinity of x squared all over e to the 3x. And again, we try to solve this, limit as x tends to infinity of x squared all over the limit as x tends to infinity of e to the 3x. We look at the top, limit as x tends to infinity of x squared. We know that as x gets larger, x will tend to infinity. So as x grows, the top will go to infinity. And the bottom, as x grows, the bottom will go to infinity. So we're going to have an infinity over infinity case. This is another example of employing L'Hopital's rule. So let us employ L'Hopital's rule to solve this. So we have limit as x tends to infinity of x squared all over e to the 3x equals the limit as x tends to infinity of d dx of x squared all over limit as x tends to infinity of d dx e to the 3x. Well, this is limit as x tends to infinity. D dx of x squared is 2x, and limit as x tends to infinity, the derivative of e to the 3x is just 3e to the 3x. But once again, as x tends to infinity on the top, that becomes infinity, and on the bottom, that becomes infinity. So that didn't help us, but what we'll do is we'll employ L'Hopital's rule again. So we'll take the second derivative. So taking d dx of 2x and limit as x tends to infinity d dx of 3e to the 3x, we'll get limit as x tends to infinity. The derivative of 2x is 2, and on the bottom, limit as x tends to infinity of 3e to the 3x. The derivative of 3e to the 3x will be 3 squared e to the 3x. So on the top, the limit as x tends, that's a constant, so that would just be 2. And on the bottom, as x tends to infinity, e to the 3x will grow and will tend to infinity. So 2 all over a very large number will become 0. So in other words, the original limit gave us a 0, an infinity over infinity, which is indeterminate form. But this led us to a value of 0 by employing L'Hopital's rule twice. Limit as x tends to 0 of sine of x over x. And we proceeded to solve the limit as x tends to 0 of sine of x over limit as x tends to 0 of x. Well, on the top, as x tends to 0, the sign of 0 is 0, and on the bottom, as x tends to 0, x will go to 0. So we have again an indeterminate form. So let us apply L'Hopital's rule to this problem. We have limit as x tends to 0, sine of x over x equals the limit as x tends to 0. We take the derivative of the top, sine of x, and then limit as x tends to 0, the derivative of x on the bottom. Well, we get limit as x tends to 0. The derivative of sine x is cos x. And on the bottom, the derivative of x is 1. So x is 1. And on the bottom, we have 1. So the answer is 1. So you can see how we transform the kind of a difficult limit of indeterminate form of 0 over 0 to using L'Hopital's rule and getting an answer of 1. That brings us to the end of the lesson. I hope you enjoyed it. Please click like, subscribe, and comment below, and look forward to seeing you again. Take care. Have a nice day. Bye-bye.